I recorded this video on, sorry about that, on Earth producing abundant hydrogen naturally, and I opened with a statement on Turkey as a source of hydrogen as well. And there I mentioned a town called Antalya in the context of the earthquake that hit Turkey pretty hard, and Syria back in February, maybe February 6th of 2023. A very nice person, Mr. or Dr. Ahmet Yükseltürk, sent me an email after watching the video that I was actually wrong. Antalya was not at all affected, not directly anyway, by the earthquake. It is Antakya that was hurt seriously by the earthquake. Yeah, so it's Antakya that was hit and not Antalya. So I just wanted to correct it and thank Mr. or Dr. Ahmet Yükseltürk for sending the email. Thank you. This is a nice story that basically discusses the idea of having hydrogen abundantly present, produced by natural processes within the earth, not in the atmosphere but within the earth at various fault lines where there are lots of olivine rocks which have lots of iron. So water interacts with these minerals and the minerals get oxidized and hydrogen is separated from the water molecules. And there is been evidence for a lot of times, maybe a long time, sorry, maybe 2500 years or so, where the naturally occurring hydrogen may have been used. This is a picture of the continuously burning gas seep at Chimera near Antalya, Turkey. Antalya got recently hammered very badly by the earthquake, and maybe it's almost been wiped out. It's a historical city. The gas contains 7.5 to 11.3% hydrogen by volume. These active vents have been known for more than 2500 years and are believed to be the source of the first Olympic flame. So you can see this science article that wrote this nice article on hidden hydrogen. Does Earth hold vast stores of renewable carbon-free fuel? There are arguments made by one author that even the radioactive particles produced by the Earth's core can actually break water, which is abundantly present even in the rocks throughout the system, in the Earth's mantle and crust. The hydrogen can be produced there naturally by the bombardment of these high energy particles, which are like the nuclei of helium, for example, and that hydrogen may be seeping up to the surface. Whether it's in high enough concentration to be tapped and commercially captured and sold and moved, etc., is a question. Hydrogen per kilogram has much higher energy density than oil, but its volume is very large because it's a very light gas. So to compress it, you have to bring it down to something like minus 253 degrees centigrade, which basically makes it financially or economically not viable. So whether this will be used anytime soon is a big question. But there is a nice story that in 1987, when there was a well dug in Mali, this nice village name called Burake Bugu in Mali, some guy went to look in and he had a cigarette in his hand and the hydrogen made it explode and he got burned in his face. Then people realized that this fire is going to burn for a long time, and it did burn, and then they put an engine on top and so on and so forth. Eventually the Malian businessman and former presidential candidate Aliou Diallo cast his vote in the 2018 elections. Now his company is preparing to extract hydrogen from underground deposits near the village of Burakebugu. So he is very optimistic that there is enough hydrogen there to supply the world several million tons at least. The hydrogen rainbow, just to catch up on the background, you may have heard terms like gray hydrogen, blue hydrogen, green hydrogen, and so on. So researchers use colors to distinguish between different kinds of hydrogen. Gray hydrogen made from fossil fuels which release carbon dioxide and add to global warming, hence it's called gray. Blue hydrogen, same as gray hydrogen, but the carbon is captured and sequestered, so you're still using fossil fuels to catalyze or electrolyze or whatever method you use to split water and get hydrogen, or split methane or react methane with some other molecules and get hydrogen out. Green hydrogen made without carbon emissions by using renewable electricity to split water. Gold hydrogen trapped from natural subsurface accumulations that we are discussing here, and orange hydrogen is stimulated by pumping water into deep source rocks, kind of like how we squeeze out shale gases and so on. Okay, just to summarize the processes, Earth's hydrogen factories. Hydrogen is a carbon-free fuel, but manufacturing it is dirty and expensive. Some researchers believe cheap, vast, potentially renewable source of natural hydrogen sit underground. So the key here is renewable. Why is it renewable? So unlike oil and gas, when you tap into hydrogen and take it out, the water and the minerals are continuously interacting to produce hydrogen continuously. So it's not something that will run out. This factory will run forever. So it's in some sense also a renewable source of natural hydrogen. So you have rainwater, water infiltration into the deeper parts of the earth, and there is basement rocks where H2O and maybe alpha particles from the radioactive decay are interacting to split water to produce hydrogen. So we'll look at the processes in a minute, and we will see in a minute that maybe even processes like the fairy circles or the so-called Carolina bays are produced by hydrogen and its interaction with vegetation and oxygen and other things. So there is microbial consumption happening as well. There are hydrogen seeps, so the places where cratons occur with exposed minerals where water can interact with minerals to produce hydrogen. And you have, of course, olivine bands or green belts where you have water interacting with iron, basically banded iron formations. For example, iron is highly oxidizable, so water interacts with these olivines to produce rust and release hydrogen by splitting water. So there are hydrogen traps in sedimentary rock layers, and there are slit layers as well where you can tap into to capture the hydrogen. And there are abiotic consumptions at fault lines or where the ocean crust is splitting apart, like the mid-Atlantic, where a lot of these processes go on. So you have hydrogen and water here, so CO2 plus H2O can be pumped into iron-rich intrusions, so then CO2 can just get converted to calcium carbonate, so you create carbon sequestration as well as pumping out H2O, so you have a co-benefit there. That's really great. What are the generation processes? You have radiolysis, so trace radioactive elements in rocks emit radiation that can split water. The process is slow, so ancient rocks are most likely to generate hydrogen. Secondly, the so-called serpentinization. At high temperatures, water reacts with iron-rich rocks to make hydrogen. The fast and renewable reactions called serpentinization may drive most production. Right now it's believed that almost all of the naturally produced hydrogen is coming from serpentinization. Deep-seated streams of hydrogen from Earth's core or mantle may rise along tectonic plate boundaries and faults, as we see here, faults here and seeps here. But the theory of these vast deep stories is controversial. So there are some big proponents of this idea, but actual evidence is still to be confirmed in terms of how vast they are in their availability for extraction. Loss mechanisms, of course, seeps. Hydrogen travels quickly through faults and fractures. It's very light gas, so can easily get through every little available fracture and faults. It can also diffuse through rocks. Weak seeps might explain shallow depressions, sometimes called the fairy circles. This is also a theory. Microbes in shallow layers of soil and rock, microbes consume hydrogen for energy, often producing methane. So these are chemosynthetic microbes. Abiotic reactions at deeper levels, hydrogen reacts with rocks and gases to form water, methane, and mineral composites. Okay, so that's up here, abiotic consumption of hydrogen. In terms of extracts, you have traps here. Number 7 that we looked at, hydrogen might be trapped like oil and gas by drilling into reservoirs trapped in porous rocks below salt deposits and other impermeable rock layers. Sorry about that. Other impermeable rock layers. Direct extractions, number 8 here. It might also be possible to tap the iron-rich source rocks directly if they are shallow and fractured enough to allow hydrogen to be collected. Enhanced recovery, like we did for oil. Hydrogen production might be stimulated by pumping water into iron-rich rocks, just like we pump CO2 and water to extract shale and oil. Adding carbon dioxide would sequester it from the atmosphere, slowing climate change. So this is imagining that there is double advantage there of extracting hydrogen and also pumping down CO2. Hydrogen seepages may explain mysterious depressions often called fairy circles. Some are more than 1 kilometer wide in this LiDAR image of coastal North Carolina, hence they are called Carolina Bays. Okay. Here is a large fairy circle in Brazil that leaks hydrogen, is curiously devoid of vegetation. So one has to understand what are the processes that are happening that brings up hydrogen and suppresses vegetation but creates this circular feature as well. There are many ideas as to why these get circular in shape, but scale selection is always a very interesting problem. For example, streams, rivers, etc. tend to have this wavy features that look almost always similar. In 2019, the startup Natural Hydrogen Energy drilled the first US hydrogen well amid corn and soybean fields in Nebraska. So you can be sure that if hydrogen is at all available and being naturally produced, there will be a gold rush to tap into it, and hopefully it is abundant, and like oil and gas, it will begin to be extracted, but much more safely than we have done with oil and gas. And oil and gas companies have created so many holes on the planet's surface that maybe they will be also useful for extracting hydrogen. Okay, so this story is yet to play out in terms of its economic feasibility, and of course access, quantity and quality of energy is going to matter. And then there are of course other issues of how to use it in fuel cell technologies, which haven't caught up with the speed of the batteries, for example. But the idea is that trains, planes and big vehicles like transportation trucks cannot carry huge batteries, so maybe they will work better with hydrogen. But of course hydrogen has to be compressed and liquefied and so on, which has other issues right now in terms of life cycle and it being carbon neutral itself. Right now mining for any of these things is very dirty, right? So here is a map from another paper which I forgot to put in here. I think the name is Zigonik, who has a nice review article in Earth Sciences, which you can look up. These are the discoveries of Earth across the planet where H2 is greater than 10% by volume. As free gas, these green pins here in coal basins, faults, geysers, hot springs, etc., hydrocarbon fields and igneous rock locations or fault lines. And you also have kimberlites, ore bodies, Precambrian rift zones, salt deposits, sediments, metamorphic serpentinization sites, volcanic sites, and as gas inclusions, again, coal basins, igneous rocks, kimberlites, ore bodies, Precambrian salt deposits, sediments, and metamorphic, ultrabasic, volcanic, and as dissolved gases in aquifers and water from hydrocarbon fields. This is a nice long 45-50 page paper that you can look at with lots of information on the processes that form them and so on and so forth. So that's a short story on how there may be abundant hydrogen stored within the Earth's what do we want to say, Earth's body, not in the atmosphere, starting from the core into the mantle, up into the crust and seeping into the surface as well. Maybe this will serve as a good addition to all the other renewables like solar and wind and nuclear, hydro and so on, and will solve the problem soon for global warming targets as well as decarbonization, net zero and so on and so forth. So nice optimistic story, but we have to wait to see when it becomes commercially viable at utility scale energy supplies. Okay.